In this video, we will state the key features of the Azure AI Foundry Agent Service. Let's keep going now and talk next about some key features of the Azure AI Agent Service, also known as the Azure AI Foundry Agent Service. It's worth re-emphasizing that other name from time to time because of how important the Azure AI Foundry is in this conversation. Here is the comprehensive block diagram. Now, there isn't going to be enough time to talk about all of these. However, we will hit some of the high points, such as tracing, AutoGen, Semantic Kernel, and managed orchestration for multi-agent workflows. Let's get started. The features that we wish to cover are basic versus standard setup, multi-agent workflows, tracing, and content filters. Let's start first with basic versus standard setup. You can see there that standard is also referred to as use your own resources, and this gives us a clue about the fact that basic versus standard refers to how the underlying resources for our agents, such as search or storage, are going to be managed. Basic and standard are actually project types. Agents created in a basic project will rely on multi-tenant search and on storage resources that are fully managed by Microsoft. On the other hand, with a standard project, agents will rely on customer-owned single-tenant search and storage resources. So here we have full control and visibility, and of course, we also have to pay commensurately. So a little more on the basic setup. If we rely on basic projects, then we have to use Microsoft-managed resources. These are multi-tenanted, including search as SIL in storage. We will not have direct visibility or control over these resources. Despite these limitations, this is a simple way to get started quickly, and we still can customize our AI services resources, so that important bit is still under our control. This is currently configured as the default in Azure AI Foundry. The standard setup, on the other hand, allows us to bring customer-owned single-tenanted search and storage resources, so we can have our own Azure storage account. WeaveChain can use Azure Cosmos DB for no-scale and Azure AI Search, all our own resources. That, in turn, gives us full control and visibility over the resources, but we also will incur costs based on our usage of those individual services. This offers true enterprise-grade reduction, compliance, and control. The implication of this last statement is that the basic setup does not. That is worth keeping in mind. Next, let's talk about support for multi-agent workflows. This is a powerful feature because we could build multiple specialized agents that then work together. The benefits of multi-agent workflows are obvious. We can coordinate multiple specialized agents, and this also leads to modularity. There are no large monolithic agents which do everything and become hard to manage and maintain. There are several tools available for building multi-agent workflows. The first of these is internal, so connected agents within the Azure AI Foundry allows to define a primary agent, and then delegate tasks to other specialized sub-agents without needing any custom orchestration. Then there is Semantic Kernel. This is an open-source SDK by Microsoft which enables developers to build and orchestrate AI agents. Here we can integrate LLMs with native code, plugins, and external services. Finally, there is AutoGen. This is an open-source framework from Microsoft Research. It's designed to construct multi-agent systems, and it allows multiple customizable agents to collaborate through conversations and the use of LLMs, tools, and human inputs. Please note that both Semantic Kernel and AutoGen have a Microsoft angle to them, but they are not exactly Azure AI tools, and that's why we put them down here as external. Another important feature here is tracing. This, remember, is tracing in the context of the Azure AI Foundry. We have covered this already in detail while talking about Gen AI, and the Azure OpenAI resource was just a very quick reminder. Tracing allows us to capture events and states and is enabled at the level of the Azure AI Foundry, and it relies on OpenTelemetry and Azure Monitor. Tracing is particularly important in agents, and that is because we need it to identify inaccurate tool calls, misleading prompts or responses, high latency in specific steps. Remember that these revised Samal tailset can be cube-type Terraform, and also low-quality outputs. Finally, let's also talk about content filters. These again have special significance in the context of the agent service. We need these to detect harmful content in both prompts and in responses. We will make use of Azure AI Content Safety. For each category, content can be assessed at wide different severity levels, such as safe, low, medium, or high. And we can configure the sensitivity of our filters, deciding at which severity level content should be blocked or annotated. We can use content filters to catch hate speech, sexual content, violence, self-harm, jailbreak attempts. Please note that this requires the use of a special type of filter known as a prompt shield, as well as to detect copyrighted or protected material. Content filters can perform two operations on harmful content. They can block it. This will prevent the harmful content from being processed or displayed, or they can annotate it. There's a longer list of Here, the service will mark the content with relevant categories and severity levels without blocking it. This allows for monitoring as well as custom handling.